what are the expectations, what are the emotions that we see in the math class, and share with you some of the insights about it, and also something that you can do at home. Yeah. um, so Yuvrani and I, both of us, I'm Lakshmi, both of us handle math in grade 7 together. And so Yuvrani will start the session.
Okay, good morning. Thank you so much for coming. So today's purpose is all about. Yeah. So today's purpose is all about what are the emotions we are going through, particularly in classroom. What are the emotions these kids are going through, and we are just going to have what are the routines in our classroom. Daily math class goes, then the expectation which we incorporate in the classroom. Then we would like to show how the classroom environment will be. So, not taking much time of yours, let's just quickly go with an action.
Okay, so what we have planned today is we will start, usually our class starts with something called a quick five. Okay, so we give them five questions, which is supposed to be like a revision. It can be a recap, it can be something that is preparing them for the upcoming classes. It can also be something that they haven't seen, so each day it is different. For example, yesterday it was quick 2, because we knew that these two questions will make them think. It will require them to apply certain concepts that they have learned, and it will not be possible for them to solve five questions. So yesterday it was quick 2. So it's quick 5 means usually it is simple questions. It will be a recap, it will be a mathematical fact which are very important for them to learn, so that their accuracy and the speed improves. Okay, so today we'll try with the quick 5, and we would be happy if you can try. So there are 5 questions. Okay, there is no. Another thing we do is not to scare the children. We give them enough time to think, and we also provide them with the leading questions, those who need that kind of support. So the first question is, you want to read? Do you want to read?
So the first question is, I have cows and chickens in my farm. I counted 100 heads and 320 legs altogether. How many cows and chickens does that make?
These are the questions that we have already done in class. So the children, what they did was, I have counted 100 heads. So they came up with combinations for 100. So what are the different combinations? Like starting with 10 plus 90, then 20 plus 80, then 30 plus 70, like that. Then they substituted the legs for the chicken and the cow in that equation. So if it is 40 plus 60, suppose it is 40 plus 60, if I have 40 chickens, then it is 80, and 60 cows means it is 240. Yeah. So they did that trial and error, and then they came up with the answer. I think I gave away the answer. The next one is kind of very simple. If triangle is 9, square is 16, pentagon 25, then what will be octagon? Excellent. Then 20 square. Yes. If 6 square times 5 square is the square root of x, what is x? 6 square plus 5 square would be 36 plus 25. Yeah. No, so 6 square, yes. 6 square times 5 square. Yes. So 36 times 25. Yes, I think you are quick in math. That's another question that keeps coming in our class. Yeah, you can check it. Somebody to. So root of x is 900. Root square root of x, which is 30. Yes. Yes. So it is square. So the square root would be 6 and 5. The product of, yeah, so these are very important things that we kind of encourage in class, the different strategies that the children use. So when there are some questions which are not very straightforward, like the first question, then the fourth one where she said it is a square root of x, so 6 square can be 6 and 5 square can be 5, so the answer would be 6 times 5, 30. Yeah, the product of two numbers is 100 and their difference is 15, 20 and 5. So here, another uh, focus is on the vocabulary. Like for example, even now when they say sum, difference, product, all that children get confused, and it is very important that they understand this, because when they come to algebraic expressions and when they have to write the expression for in words, it is very important that they understand that they use these words which are product and sum and difference and all that. Square, square root, again that is the confusion they have. Square, what is cube root, even the symbol. So we spend quite a lot of time in helping the children to read the question the way it is supposed to be read, so that they understand what it means, and they are not missing out on the key the key words and vocabulary in that. Yeah, so usually we start with the quick five. Then we have something called a math talk, which can be either a puzzle which we put, which will be a combination of some of the concepts that we have learned in the past, or it would also be a math talk. Something that is a big hit is the estimation mysteries in our class. So we have clues and they come to the answer after reading the clues, which will be a combination of fractions and decimals and all that. And depending on the topic that we are dealing at that time, we will also have an activity which is a group activity. So we have actually thinking that there will be a lot of parents. We have decided, we have come up with four um, corners, but you can choose. We have one corner is a tangram, and then we have one tarsia puzzle, then we have a data interpretation, and then we have a dominoes on power. So which one would you like to try? The three of you can try together, and maybe the three teachers can try the other one. Tangrams? Yeah. Here. So this is so the tangrams usually has the squares and the parallelogram and the triangles. And using these, first you have to make a square. Yeah. Once you do that, you can also try one of the shapes from this book. So what kind of emotions when you are trying to solve a problem or a puzzle, what are the kind of emotions that you went through?
I'm always excited. It's one of my favorite subjects, but I can tell you what I see is anxiety, fear of failure, and then all those things I've seen in kids generally. Getting frustrated.
Getting
Actually,
frustrated.
I think the main thing is the fear of not being able to do it and the anxiety of having to do it in time.
Mm,
If I always encourage my daughters to actually think like they have nothing to lose, only then you can learn.
correct.
Yeah.
So also to, yeah,
Only then I think the wow moments happen, you know. Oh wow, this is how it
absolutely,
is
yeah,
done.
yeah,
I think anxiety.
anxiety.
Yeah.
And do you also feel that, oh my God, I am a mother and I do not know how to put it together? Is it going to be, these are the emotions that we see. I have done some children, they are genuinely good at math. And when they come across a problem which they cannot solve, they really leave it. They don't want to go further because they feel that in spite of knowing so much in math, I am unable to solve it. That is where we have to be the people who kind of motivate them and tell them that no, it's not, like how you said, there's nothing to lose, everything is a process of learning, and mistakes are the, it's a stepping stone for success, which we usually say, no. So they have to embrace mistakes and struggle and try to do it couple of times, but it is difficult. That resilience and the grit and all, it has to happen. But I think once that is in place, the fear towards math, or the whole thing about, oh my God, math. Even now, when we go into the class, that is the kind of reception we get. Oh no, we have math, is it? So we just want to see how we can break it. It is not easy because sometimes, as parents, we also pass on our anxieties to our children, right? Unknowingly, when it is math and when they come to us to for any doubt clarification, we say, I have never been so good at math. So hello. Hi. So yes, I know. We were just talking about the emotions that children go through when they are given a problem. We were just doing a tangram, and we were just would you like to share something about what happens at home when it is math? I,
Actually, my son never says anything. He does everything on his own.
Correct.
Even Max, he does everything on his own. So
So has he ever felt that he's not being? What is the emotion? What is it that he comes and shares back home about the math and about the
Max
subject?
is very excited to do all the problems and even the problem of the week. I think last week only he was upset that he was not able to do it.
Oh, okay. So that is upset,
Yeah,
yes. So
yeah.
that is again, that is something
And he
that,
was asking me also, since I was busy, I was not able to help him. Otherwise, he wanted to do it. I don't know whether he did it or not.
okay.
But other than that, he is okay. Whatever other subjects also, not only maths. If there is an exam, he prepares on his own. He doesn't need much help.
Right. I know most of the children are they have good work habits. They are they are very enthusiastic in the class. Too much of enthusiasm sometimes, which we have to curb. And we also feel that they are. It's a bunch of students who really enjoy struggle, enjoy learning through a repeated practice and all that. So even for the math assessment, the moment the assessment is over, they know that they have made a couple of mistakes. The first thing they do is, can we have a retest? So can we have a retest on the same topic? So that shows that they want to become better and better. So it's not that every time you get everything right, but you understand where you have gone wrong. So we immediately kind of discuss the question. So it's only 20 minutes. So the rest of the 20 minutes we discuss the paper, And then you can see the emotions, real emotion. They'll be like, oh my God, I forgot the negative sign. I knew this. And then they'll say, Auntie, you know that I know this, right? So you should give mark. So those kind of dealings also happen. So we just wanted to share with you some of the expectations that we have in the math class, and how we feel that that would help them when as they go up in grade 8, when they have the checkpoint. There are certain things that are very important, for example showing the working and all that. Yeah, so can we show those pictures? Is it frozen? So this is from one of the students notebook, and it is homework August 5th. And this is the same homework done by another child. So can you, what do you think, what is the difference? Questions are there, the steps are there. So which one do you think would help the child when he or she is revising or going back through the notebooks? The second one. So this is one reason why we want the children to write the question. So one thing that they keep saying is, why do we need to write the question? It's already there in the textbook, or it's there in the slides, or why don't you upload that? So these are the questions that we usually get. So what we tell them, which you can maybe say something similar back home, is that when you are copying question, it is not just copying question, you are reading the question. Because most of the times what we feel is that because they haven't read the question correctly, they do not understand what they are supposed to do. So when you are copying the question, you are reading, you are analyzing the question, you are also thinking in your mind what is the approach that I need to take. So it is not just a blind copying of question. So which we have been telling them from day one, and now we see a lot of difference. We wouldn't say 100%, but they are showing a lot of change. They don't argue with us anymore about the questions, and they are also thinking. So again, reading question, for example, when we started the powers, the indices, they, most of them read it as 2 2 instead of 2 square, 3 3 instead of 3 square, 3 4 when it is to the power of 4. So those kind of vocabulary also is very important, because when you read it as 3 3, you might say that it is 3 times 3, right? So if it is 3 to the power of 4, they will say 3 and 4, and they will write it as 12. So these are the constant mistakes that we see. So we are trying to make them read the question the way it is supposed to be read, and then copy them, and then do the show the steps. So again, they know, many of them do have excellent mental strategies, I would say, but when they go wrong, they do not know where they have gone wrong. So when you write the steps, it is easy for you to point out that this is the place I need to work on. So we have been working towards that. So when they come back with the homework, and when we say that you need to copy the question from the textbook, please encourage them, tell them this is the reason why aunties are insisting, and what they will gain. It actually reduces the time for solving the problem if they are reading the question correctly. So we just wanted to show. Right.
But if there are big word problems, I'm not involved
Absolutely.
with the academics, so I don't know. If there are big word problems, I would suggest that it's okay for them to just show a proper working step by step than to copy the word problems.
Yes.
I hope we are on
So,
the same page.
absolutely. So, when it is a word problem, what we tell them is, please write down what is given in the question, and then start from there. We do not want you to copy the, especially if it is a problem of the week which runs sometimes two paragraphs. It doesn't make sense, but make it a point to write down what is given and what is to be found. So, the problem is that they don't look at what is given, They don't read what is to be found. So when we explain it, oh, only this much, I didn't know that. So that is the kind of reaction we get. So we want them to read, even if it is that reading tolerance for math, which when it is the problem of the week, we give because we want to increase their reading tolerance. We want them to read those two paragraphs and understand what needs to be done. Yeah, so absolutely, we do not, and we have told them very clearly, you don't need to copy the word problems. If you just need to write what is given and what is to be done and the steps on how you solve the problem. Yeah. So when we are looking at homework, we have homework every day of the week, right? So what we are trying to build through this is to a habit, a work habit, to instill that work habit, and to be in touch with the subject on a daily basis. So what we go back and forth. There are days when we give homework based on the concept that is running in the class. If we feel that the concept is not strong enough, that the child will not be able to do by himself or herself back home, then we kind of give worksheets which are a combination of the concepts that are already done. So we also want to give simple, the division, the long division. We found that long division is a place where they really are finding it difficult. We had a question, 80 divided by, they wanted to find the percentage of the, so the question was a data interpretation where they had to find the percentage of days where where the temperature was above 15 degrees Celsius. So they found that the number of days from the bar graph, that there are totally 80 days, and it was given that this experiment was conducted over a year. So it is out of 365. So to do this calculation of 80 divided by 365 and then find the percentage, almost everybody struggled, because for them that long division was something that they did not have the patience, to be very frank. So we thought that we will give them at least 4 or 5 long division in an evening where they have to sit and do the, because yes, of course they ask these questions, auntie, when do we use it? Because as we grow up, we are going to use a calculator. So we keep telling them it is, even for calculation, this is the time when you are cognitively building your brain. Okay, it's a mathematical thinking. You might feel that I need to only arrive at the final answer, and the process is not something that I am interested in. So we keep telling them that the process is very important. The process of applying the formula, finding out, and also thinking, okay, only 80 days out of 365, will it be 50%? Think logically when you get an answer. How much would it be if it is if it is 10%? What would be the number of days? And then think like that, and then when you compare it with your final answer. So these things we keep insisting. So we were also thinking that multiplication, 2 digit cross 2 digit, 2 digit cross 3 digit, they all have a little trouble when they do that. Yes, of course, these are all redundant when they grow up, but it is very important now because the brain is getting tuned to the mathematical processes. So these are the things that we keep in mind. The time required to complete, we do not expect them to go beyond 30 minutes, but there have been a couple of days when we gave them a little more than usual, but we gave them 2 days. So they came and told us it was not enough. So we told them you can take one more day, but we will keep in mind that it does not exceed 30 minutes of their homework time. And we are also looking at the future success. So some of the mathematical processes, some facts, the multiplication, so they are good at till 12 multiplication. After that, when it comes to 14, 15 and all, somewhere if you are good at calculating that, whether it is using any mental strategies or by learning the tables, we want them to kind of recap on that. So something related to that. So these are our thoughts on homework. And the assignment offers support. So the last point is because that is where we do not give homework unless the children are clear of the concept. Otherwise, the homework will be just asking parents or asking their tutor or going online and finding the answer. That come, that is how they will start thinking. So we give them, unless they are very sure about the concept and we feel that they can do it by themselves, we do not give. But these homeworks will also have some higher order thinking. So some children, they find that difficult, we say it's okay, but those who can do it, we encourage them to do. So that is the kind of differentiation we do in the homework. Yeah. All of you might have heard of growth mindset and how struggle and repeated practices, and also praising the effort, praising the processes rather than the final product. All these have been making rounds. A lot of research done based on that. So in our classroom, what we do is, it is a non-judgmental classroom. We have children who are really good at math. We have children who are at the grade level. We have children who are still trying to make connections with the different topics, ability to, they are still trying to apply what they have learned in order to get a hang of the concepts. So we, everybody, in fact, the children also are very good, no matter what, how, I wouldn't say any doubt is a silly doubt, but whatever be the question, it could be some basic doubt. The children are very, courageous enough to talk to us, to ask us questions in the class. Another thing is, we not emphasis on the, not more of a focus on the speed but on the accuracy. We tell them that if you can do two sums, those children who are slow, we ask them to kind of practice. With practice, definitely the both the accuracy and the speed will increase. And we also tell them that you need to go back and get your mathematical facts, the math facts, the tables, the divisions, the squares and the cube roots and all that in place, so that some of these calculations become much more easier. Then we also do, uh, this is something, our anxiety towards the subject, it is better that we don't pass it on to the children. I don't like math, I was really bad at math, so maybe you have taken my genes, or you have my this thing, that maybe we should stop. Because even though you may not be very fond of the subject, but you have to put a brave front and say, wow, this is, let us do it together. And then we will end up learning from them. We learn every single day, because the kind of thinking that they have is not what we have gone through when we were learning math. So this is something that we also follow in class. Next slide. Yeah. So, and this is what we do in class. We have non-judgmental, very safe, very respectful. We do not penalize, or we do not ridicule anybody for not knowing something. We provide the guidance and support. Be two teachers are there, so we kind of go around and sit with one-on-one with some children who need that support. There's a lot of humor, of course, and yes, we try to make it as engaging as possible. So, yeah.
This was I don't know which group did it. It's a very famous paper. In that, there were a study done in a group of students. So there's one group of students who are very, very good with mathematical concepts. They work in that kind of a speed, and they do very well. So there is one group of students like that. Another group of students, they do struggle, but they were putting the effort. Okay, so in this study, what happened is the scientists or the researchers, when they gave questions, the group which does the questions with that kind of speed and the pace didn't take up a question which is higher to that ability, in the sense that they might go wrong in that question, they didn't want to take it. The other ones who were praised for their effort, they may not get it right, but they stuck onto it and they were ready to work it out. So when Lakshmi was talking about this, that was coming into my mind. In our days, if we were given opportunities to know, or praised for the kind of effort that we were putting in. We might not have had that kind of a speed, but the kind of thought process that were there in that would have developed. No, so that this is something that we need to. So the kids who give up on a question when they just don't get it, for them it is, how is that I don't get it? That is something that we need to work on. And there will be a group of students who are struggling through it. They may not get the right answer at this point, but we cannot allow them to give up. So these are entirely two different aspects, and scientists are looking into it. Mathematics is so, very clearly you can measure it easier than any other subject, and they have done these kind of studies. I can share that paper, Lakshmi. It was an amazing one to look through and understand. So it's really, you know getting that idea when Lakshmi was talking about. And something that when I walk into this classroom, something that I see here is, and we were having constant discussions on, is how do we make sure that every student in that class learn to love mathematics? So it is that a group of students who really want to be challenged, because they will get bored in the regular set of classroom. So we are also looking at into those kind of no ways to make them into smaller groups and challenge them at some points, and make them into the group of students who need the support without making them think that I'm not good in mathematics. What we want them to understand is there is an area that they need to develop. Okay, we want, probably a couple of them, we might have to ask them to slow down a little bit, think, than just jumping through it. Some of them to give them the kind of questions that probably into a grade 8 or grade 9 level, and take them to that pathway. So tomorrow we are having a session on grade 8 mathematics and the pathways that they will be taking in the next 4 years. The YouTube link will be available. Anybody who is interested in that, please to take a look into it. Next year definitely we will do. But here itself we are thinking, and since they both are working together, we are actually thinking by second semester how we can motivate them to take them to a slightly different pathway, where they are they are very proud of what they are learning, but at the same time they are humble, not ridiculing. That's something that Lakshmi was very clear about. We do not want to humiliate a child just because their speed of mathematics is a little less than, because that child has another ability in different other areas. That doesn't mean that everybody should be good in one particular area, but mathematical thinking is something that we want all our kids to have. And I do love to be there in their classes. Okay, I do learn a couple of things when I walk in and get into the classroom. So maybe you can have a little conversations with them, just to check out, and have some little tea outside.
How are you supporting them on building comfort and foundational aspects? So this is something we were talking about. Some children, the foundation of math, which is the math facts that we call, also the ability to apply the foundational, the primary, whatever they have learned in primary and in grade 6 in solving the problems are is still not there. So what we do is we try to start the quick five that we have. We very consciously we add these questions. Very consciously, it might, some children will, oh my god, this is so easy, but it is easy because you are able to apply. It may not be easy for a child who has not got it right. So we give them, so the our quick five will always have a combination of these concepts, the foundational math, and also our homework. So we, yes, July we started, August and September we have understood the learners, their ability. So now we will also be trying to see how these from based on their individual the way they have been handling math for the past 2 months, we will be now doing some kind of a differentiated homework, where it will also be a combination of foundational as foundational concepts plus the concept that we are handling at present in class.
Really into mathematics to go for the AMC 8 and things like that. So CEMC.
gauze contest and all that. So we will be sharing the details with Hari sir is the one who is coordinating it. He is an IB teacher and he's been working with the students. So there is this program of contest mathematics as an elective that we do. Group of students who are really into it, they do take it up and they solve really challenging questions there. Okay, but at the same time, some of them say that I do like math, Andy, but there are other electives I would like to be part of. So that's fine. That's fine. That's perfectly fine. But the contest, when it comes, all the students who are into it, they can definitely try. But it's something that we encourage students who are interested to participate. Let us not.
For grade 6. In fact, it starts from grade 5. There have been, I mean, some of the children in grade 5 itself, they took it. So it's for 5 to 8. So if you go into this Waterloo University website, you will get to see about the CEMC, the Gauss contest, and all that. So what we do is one thing that to challenge the children is we take a couple of questions from the Gauss paper and then give it to children who are in need of that challenge. Not to everybody, because it is not an expectation. The expectation is to learn the grade level and to challenge them if they are interested. And so that is one thing that those children who are very keen in math can definitely try that, because it will keep making them think and improve their mathematical thinking. Yeah. 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 When we